Hey calculus kids, this is Dr. Callahan. Welcome to week 8 Wednesday. Go ahead and pause the video and answer the following 3 questions on your warmer blog. All right, so let's go ahead and take a look at today's stuff. So last time I saw you guys, I asked you to go ahead and start memorizing the derivative formulas. So the first question is, you need to know this by memory. You should see that this is as a product rule. So it's f prime times g plus f times g prime. Second one is a quotient rule. So it's f prime times g minus f times g prime divided by g squared. The next one is a derivative sign is always a positive cosine. Derivative of a cosine is always a negative sign. So make sure you memorize that, because next semester in semester 2, we're going to go over a thing called integral. And this is the beautiful little symbol for integral, and you will have a new set of formulas to memorize. So it's critically important that you pace yourself for this class. So make sure you're not jumbling everything together towards the beginning of May trying to memorize everything, because it just does not work. Derivative tangent is secant squared x. Derivative cotangent is negative cosecant squared x. Derivative secant is secant x tangent x. And then cosecant x, the derivative is negative cosecant x and cotangent x. Now today is week 8 Wednesday. Your warm-up blog is due week 9 Friday. So keep that in mind. All right, let's take a look at question number 2. So you're supposed to find the second derivative of this. So second derivative is symbolized by f double prime of x, and it's that little tick mark right there. It's called double. Whoa, that's a little weird. There you go. Double prime, because if it's a single tick mark, it's a prime. So 2 tick mark is double prime. Or you can even do y double prime. It means exactly the same thing. So as I'm looking at the 6 over x squared, you could attempt to do the quotient rule. You have the same answer, but an easier way of doing this algebraically is just using the rules of algebra with exponents. Move the x squared up, so you have an x to the negative second power, and then just apply the power rule and bring down the negative 2 times the 6, you get a negative 12x minus the 1, which gives you a negative 3 exponent. And that's the first derivative. Then you just kind of repeat the power rule again, bringing down the negative 3 to the negative 12, subtracting the 1, and then modifying this algebraically by bringing the x to the negative 4 down, and that will be your answer to the second derivative. The reason we use the second derivative is, and I explained this to you guys once before, when we go over velocity versus acceleration, you will go ahead and use that twice. All right, so now let's talk about the derivative of e to the x. I know you've been exposed to this in Honors Algebra 2. You talked about it probably in pre-calculus. It's actually really simple. The derivative of e to the x, keep in mind that it has to be an x up there. It can't be anything else. It has to be an x, is just e to the x. And then similarly, opposite of that, ln x, and again, it has to be an x. Only can't be like x squared or x cubed or 2x squared. Has to only be x. It's just 1 over x. Just very, very simple. However, it does get a little bit more complicated if you have the derivative of e to the u. And you're like, what is u? U is any other terms other than x. So it could be anything else like x squared or 3x cubed. That's not x. Derivative of this is e to the u times u prime. So for example, derivative of e to the 3x squared, and again, this is other than x, is e to the 3x squared times, what is the derivative of u? Because this part right here is u. So what's the derivative of 3x squared? 6x. So your answer is 6x e to 3x squared. We'll talk more about this. It's just a little brief introduction. Similarly, if you have the derivative of something else other than x, and in this case it is u, your answer is 1 over u times u prime. So for example, if I ask you for the derivative of ln 3x squared, it would just be 1 over u, which is 3x squared, times u prime. Well, your u is 3x squared, so it is just 6x. So your answer here is 6x over 3x squared, or if I simplify it, 2 over x. And that is your answer. Okay, so when I saw you guys yesterday, I know I wasn't there in class, I'm sorry. So we actually went over A, B, C, and D. Okay, I actually went over 2 of them. I asked you guys to go ahead and try and work on 2 of them as well. You also have the steps right here that you can actually see the steps of what I wrote down for this. I also asked you guys to give example 2, 3, 4, 5, and 6 a try because it actually does kind of go over some of the stuff involving the chain rule. So I would like to take a little bit of time to kind of go over some of them, if that's okay. Okay, so let's go ahead and take a look at example 2. Okay, for example 2, this is going to be introduction to the chain rule. And so basically what the chain rule says is that if you have something, and generally it involves a trig symbol, if you're looking for the derivative of, let's say, sine u, and u is a term other than x, because I know that the derivative of sine x is just cosine x. So if I use a derivative of sine x squared, then the derivative of sine x, sine u, is going to be cosine u times u prime. And this right here is where the chain happens, because you have the derivative with the chain. Now, so here, you know, my u is going to be x squared. So what's u prime? 2x. So sine x squared is cosine x squared times the chain, which is 2x. And if I rewrite it, that's what I will have. Now, example 2 asks you to find if y equals sine find x. And again, this is other than just x. Find the derivative of y prime. So then I could say that this right here is u. So u is 5x. U prime is 5. And I know that the derivative of sine u is cosine u. So my answer is cosine u, which is 5x, times u prime, which is my chain, and that's just 5. So my answer here is just going to be 5 cosine 5x. And ta-da, that is what you have. Let's give example 3 a try. I know that should have blown your mind a little bit. All right, well, guess what? Your minds would be even more blown by example 3, because now I'm going to throw in a square root. All right, so I don't like square roots because you can't find the derivative. Rewrite it. Put it to, I know now we're dealing with brackets, to the 1/2. Okay, so if you're going to find y prime, you first have to apply the power rule. Okay, and the power rule basically says you bring down that 1/2. So I have 1/2 minus, well, actually 1/2 times cosine Don't forget your bracket. Cosine x squared minus 1, which is a 2 over 2. 1/2 minus 2 over 2 is a negative 1/2. Times. Don't forget your chain right here. Times the derivative of whatever the chain is. So that's the derivative of cosine x squared. But this is like a chain inside of a chain because you have cosine u. So you're timing by the derivative of cosine x squared, which is a negative sine x squared, times the derivative of that chain, which is what is the derivative of x squared, which is 2x. I know, your mind is blown. So once I have this, I'm going to go ahead and cancel the 1/2 with the 2. I want to also rewrite this because this looks really ugly. I shouldn't say ugly, it's just not written appropriately, algebraically, I guess. You have an x right there. So we're going to go ahead and move the x in front of the sign, put parentheses around the x squared, and then I'm going to move the cosine down to the denominator, put it back into a radical, x squared. And that is your answer. Example 4. You guys go ahead and give that a try. It is similar to example 3. And I will give you the answer. Y prime equals 8x cubed plus 1 times secant squared 6x to the 4th plus 3x minus 2 all the way over tangent 6x to the 4th plus 3x minus 2, and it's in bracket to the 2/3. Okay, let's take a look at example 5. So with example 5, you are to find the second derivative. So if y equals secant squared pi x, I can go ahead and rewrite this because whenever you have a 2 there, you want to put it on the outside of it before you do the derivative. Make sure you put a bracket, squared. So the first thing you want to do is you want to do the power rule. So you're going to bring down the 2. So y prime is equal to 2 secant pi x minus a 1 gives you just a 1 power times, remember this is a u, so you will have to find the derivative of secant pi x, and the derivative of secant pi x, remember, is secant pi x times tangent pi x times, and I know you're like, what? There's another times that u, which is a derivative of pi x. And remember, pi is just a constant, so it's 3.14x. The derivative of 3.14x is just like 2x. Derivative of 2x is just 2, so 3.14x, the derivative of that is just pi. And so let's go ahead and make that look a little bit better. I can go ahead and put a 2 pi secant pi x squared, because there's 2 of them, and then tangent pi x. And that is y prime. Now, if we were to do the second derivative of this, you should see that this is a multiplication. So you will have to use the product rule. So then remember with the product rule, you have to go ahead and separate the F and the G. And I'm going to go ahead and just say that this part right here is F and this part right here is G. So then you're going to say F is going to be secant squared pi x with a 2 pi right here, although that constant is really going to kind of just disappear, hopefully. And then G is going to be tangent pi x. Go ahead and figure out what the F prime is and what the G prime is, and then go ahead and plug that into this product rule of F prime times G plus F times G prime, and you will have your answers from that. All right, you guys, I think that's enough. We will actually talk more about this later on, so don't worry about it if you're not quite sure. This is a little bit difficult to do. As always, the steps are shown on this link, so you're welcome to go and take a look at that. So week 8 is Wednesday, and every Wednesday we have an assessment. Today, your assessment is going to be on Math Excel. And it's on week 8 Wednesday, and it's going to be an assessment on your product, quotient rule, and trig derivatives. There are 10 questions. On average, from the past, it's estimated that you should take no more than about 15 minutes on the quiz, but you do have the entire day. So go to Math Excel, week 8 Wednesday. Make sure you get that done within a 1-week mark because I will be grading this before next Wednesday. All right, other than that, I hope you guys have a wonderful day. And as always, stay safe and healthy. Take care.